So the second example, example B, we have d over dx of sec x. So this implies that d over dx is equal to secant. Secant is the inverse or the reciprocal of cosine. So this one is the same as saying 1 over cos x. It is the same as saying 1 over cos x. So we are supposed to find the derivative of 1 over cos x. And how do we determine this one? This also implies we use the quotient rule. The quotient rule. And in our first question, we applied the quotient rule. I hope you all remember. You can confirm and check that. And you are going to see that derivative or d over dx of 1 over cos x is equivalent to, we hold this one as constant, cos x, then we find the derivative of 1, then we subtract, we hold 1 constant, then we find the derivative of the denominator, that is cos x over cos x squared. That is equivalent to cos squared x. So that implies that d over dx, we all know that this is the same as sec x. So we can just say sec x is equal to, so the d over dx of 1 is equal to 0. 0 multiplied by cos x will give us definitely a 0. Then the cosine of x, the derivative of cos x is going to be negative sine x. So negative sine x multiplied by negative 1. That is going to give us sine of x over cos squared of x. So we can simplify this one further. This is the same as saying sine of x over cos of x multiplied by 1 over cosine of x. So when we simplify it like that, we know this alone is tan x. So it's going to be tan x multiplied by, this one is the same as sec x, secant of x, and that finally gives us the derivative of sec x. Finally, the derivative of sec x is equal to tan x sec x. That gives us the answer. We are now going to our third example, and in our third example, we are going to determine the derivative of cot x. We will determine the derivative of cot x. So part C, we are supposed to determine the derivative of cot x. So remember cot x, cot is the inverse of tangent. So this simply says that it is equal to d over dx of cos of x over sine of x. Cos of x over sine of x. And in that one, we are still going to use the quotient rule. And the quotient rule states that the quotient rule states that d over dx of cos of x over sine of x, that is going to be, we hold the denominator constant, then we differentiate the numerator, d over dx of cos x. Then we subtract, we hold numerator as constant, cos of x, then we differentiate the denominator, that is sine of x over sine squared x. Where is sine squared x coming from? From our formula, we said we square the denominator. Therefore, we are going to have the derivative of cos x is equal to negative sine x. So negative sine x times sine x will be equal to negative sine squared x. The derivative of sine x is cos x. So cos x times negative cos x will give us negative cos squared x over sine squared x. So reaching there, we can factorize out negative. When we factorize out negative 1, we are going to have sine squared x plus cos squared x over sine squared x. Remember, this one is equivalent to 1. So that is the same as saying negative 1 over sine squared x. Negative 1 over sine squared x. And by having that, we can therefore say that the derivative d over dx of cot x is equal to negative 1 over sine squared x. That is the same as saying negative cosec squared x. Negative cosec squared x. And therefore that we can say is the derivative of the cotangent of x. So we are already done with that one. We now go to the last example. Now we are at our last example. We are supposed to find d over dx of cosec x. Cosec x. And in this one, remember that it still means the same as d over dx of cosec is the inverse of sine. So this simply means it is the same as 1 over sine of x. It simply means the same. 1 over sine of x. That is the cosec. Therefore, we are still going to apply the quotient rule. We apply the quotient rule. And when we apply the quotient rule, we are going to have d over dx of 1 over sine x is equal to, we hold the denominator constant, we find the derivative of 1 with respect to x, then we subtract, we hold the numerator constant, then we find the derivative of sine x over sine squared x. Over sine squared x. So by reaching there, when we differentiate 1, we will get a 0. A 0 multiplied by sine x, we are going to get 0. Then sine x, the derivative of sine x is cos x. So cos x times negative 1 will be equal to negative cos x over sine squared x. So when we have that, so that simply says or implies that d over dx of cosec x is equal to negative cos x over sine squared x. We can simplify that and have this one is the same as saying negative cos x over sine x multiplied by 1 over sine x. That is the same as saying that, and therefore this one cosine over sine is the same as cotangent. So that is the same as saying negative cot x multiplied by the inverse of sine or the reciprocal of sine x is the same as cosec x. So it's going to be cosec x. Therefore, the derivative of d over dx of cosec x is equal to negative cot x cosec x. That marks the answer. So that is how we determine the derivatives of trigonometric functions. And we still have more trigonometric functions where we can apply different principles and different concepts so that we can be able to answer this down. Thank you so much for paying attention. In our next video, I'm going to upload on how we solve the derivatives using the first principle. And we are also going to learn on derivatives of inverse of trigonometric functions and other units. Ensure that you drop down on the comment section the areas that you want us to specialize in, especially those students who are doing mathematical related courses and engineering students in campus. Be free to post it on the comment section. Click on the notification bell, turn on the notification button so that each and every time I upload new content, you are going to be updated. Thank you so much for your support. Be blessed. Again, let's meet next time.